Let us move on to the next presentation. Our next speaker is Antonio Garcia. He is a member of the official technical engineer corps, and he will talk to us a little bit about topography. We've had a little problem with the presentation, but anyway, my name is Antonio Garcia. Work for the official technical engineering corps, and we are technicians in geomatics, topography, geodesy. This is a little bit the outline. Let us begin with some background. The topography technical engineering from the beginning of times devoted his time to identifying topographic plots and performing cadastres. And we see in the drawings that when there were floods, all the plot boundaries disappeared. So they used some ropes to reestablish the boundaries, and depending on the size, the owners were to pay more or less taxes. Here you see the this same type of engineers some time later. Technical engineers specializing in topography were very important when working and designing entrances and mines and also railways. And you must realize that cartography has always been present, and cartography is based on geodesy. We have geodesic vertexes in Spain, so we can have one single reference system. Here we have examples on the left of historic cartography, and on the right we had geodesic vertex. So the cadastre is something in the plot cadastre is one of the main activities of us engineers. Now cartography has evolved. Now we have digital formats. This transformation to the digital world began in the 90s. This is a WMS service on the screen, and we can load ortho photographs, among other possibilities. Let's see the fields of application or implementation. So we've seen the history of topographers, and this is the kind of image we have of topographers. People on the road, outdoors, and looking through these devices. Here you see that we can georeference cadastral cartography thanks to WMS. On the right we had the cartography without referencing. We can load the cadaster, so everything is georeferenced. If AutoCAD is a basic version, you cannot load WMS or orthophotographs, but here with gvSIG you have both things. Another field would be cartography and geodesy. This is something that topographers have done. The idea on the left, you don't see a map. It's not a map of Spain, but rather geodesic vertexes on the map of Spain, and we use those vertexes for plotting and zoning purposes. This is the Spanish cartography using ISI, and everything is supported by geodesic vertexes. You see the different motorways, roads, you have streets, you can zoom in and more and more. You see villages, you see the streets, and this is all thanks to the geodesic vertexes. Let me show you another example. Here you see a study conducted by a colleague in South America. Also, cadastre and property ownership. This is something that us technical engineers do. Here you see a person measuring a plot. The borders are not clear, and this person can perform a disambiguation. Here you see the SIG. Here we have the topography, and let's see the discrepancies between the reality and cadastral cartography. So we have to continually correct. You see the differences here. The path is moved, and there's a little piece of plot that has become separated from a larger plot. So that needs to be corrected. Now, geographic information systems. You are used to seeing and working with GIS. So us technical engineers are qualified to collect data, and I've shown you some pictures of technicians working in the field, and this is the image people have of us. But we also perform addition. A lot of cartography is on paper. We only have hard copies. So we need to digitize information and therefore treat the information through tables. We use different media, paper, different file types. Here you see everything that can be performed via GIS, and this can be used on a desktop using TomToms or GPS locators, tablets, mobile phones. This is an example with a few layers. What about teledetection? This is one of our areas of work, and numerous professionals don't know that teledetection receives a lot of information in university. What about photogrammetry? Archaeologists are used to working with the end product, as we heard this morning. Similarly, photogrammetry is a very difficult thing to do, and we're at the other end. So archaeologists only used the final product, and we are at the opposite end. We produce all of this information, and it's very difficult to do, and it's hard to do. And this is the photo interpretation with mirror stereoscopes. And this is something that really amazed us in university. Now, this surprises very few because it's done digitally. Here you see different aerial ortho photographies, and you can actually generate digital models of the terrain. Geophysics is another area of knowledge we're involved in, and this is a screenshot I took yesterday. It shows tremors and shows numerous data. Here you have the geoid model. If you're no specialist, this might sound bizarre, but at the end of the day, you get elevations, and this is especially useful in massive projects. We also have LiDAR data. So those of you who are aware of state-of-the-art technology will know that this collects data and processes data, and the processes require great accuracy, and this is something we work on, really being accurate. We had digital models with the photogrammetry, but LiDAR is even better. You have a greater accuracy, and it covers all the country. Then we also have the scanner laser. We held a meeting in one of Valencia's main square, and we decided that prior to meeting, take an image of this square, capturing thousands of points per second. Here you see the facade of the cathedral. So you must know that all of this is studied in university. We are technical engineers, so this required a 3-year undergraduate degree and then a second specialization degree in topography and geomatics. So now it has become a undergraduate degree as such. It's a bachelor degree, and here you see all the different subjects and credits in the first year of the bachelor degree in geomatics and topography. This would be the second year, second course. You have physics, mathematics, business management, photogrammetry, teledetection, geology, databases, cartography, SIG, GIS. This would be the third year. You have advanced teledetection and photogrammetry, geometric geodesy, works topography, physics, civil engineering, cadastre, and urban planning. And this would be the fourth year. A little bit of English language, and most subjects are focus on GIS, and it's really, really practical. Our alumni are now working in the central administration, regional administration, local administration, and businesses. So, as regards the central government, they are working in the National Geography Institute, in defense, research and development projects in universities, also in the Ministry of Public Works and Infrastructure, in the Ministry of Agriculture, Food and the Environment. And also we have the regional administration, and they work in cartographic institutes, regional ministers, and the town council. And then also in the local administration would be town halls and similar and local agencies. And then as regards companies, they work in SMEs and also in larger companies. In conclusion, gvSIG allows to treat an endless geographic data, making the task of technical engineers in topography and cartographic and geodesy engineers easier. And I think that the technical profile that we contribute with is very useful for numerous activities. Geomatics specialists work in multidisciplinary teams, contributing with advanced technical knowledge and managing projects regardless how large or small they might be. The engineers used to have very basic tools, but now have at their disposal many things like GPS instruments, LiDAR technology, and we make the most of tablets, smartphones, and by this I mean that the industry has been modernized at a great speed. That was a list of the people I would like to acknowledge. Thank you so much for your attention.